of all, I want to welcome you all to JavaScript, the hard parts. Part of the Hard Parts Codesmith series is this workshop, Callbacks and Higher Order Functions. So we are going to be exploring this concept this evening through some diagramming and some discussion and some thought experiments based on what we know of JavaScript as we try and extrapolate how callbacks work, why we might want to use them. So callbacks and higher order functions. Hooray, hooray. So this concept is one of the concepts that is going to be included in the technical interview. It is also a concept that a lot of other JavaScript concepts are going to make use of. So we are going to be looking at the reason why we might use callbacks and higher order functions in today's lecture or not lecture, but workshop. And we are going to be doing that by looking at some demos. We're going to be building out some shared vocabulary and kind of a shared way of examining these things through diagramming. And so I'm going to ask y'all to participate in this diagramming. And by doing that, we'll be able to kind of really cement some of these concepts. So callbacks and higher order functions, one of the most misunderstood concepts in JavaScript. I don't know if it's the most, maybe it's one of the most, but a lot of folks, a lot of engineers will use this without really understanding what's happening under the hood or maybe why this was developed and why it's so powerful. So we're going to explore that today through some simple examples, build out that conceptual understanding. The reason why these concepts are so important is because they are what power these methods, these built-in methods: map, filter, reduce, for each. Anyone get to this part of CSX yet? Anyone start working through these problems? Yeah, they can be tricky. For those of you who have not gotten there, I'm sending you all the good vibes for when you get there. These are super powerful methods that we have available to us in JavaScript. And there are other pieces that not listed on this slide, other pieces of JavaScript that rely on callbacks and higher order functions that are what make JavaScript as powerful as it is. It also makes our code more declarative and readable, and we'll see that as we as you work with it more. And we already said this, it's going to be part of the technical interview, not just for Codesmith, but also more often than not for any technical interview for future roles as well. So something to keep in mind. Anyway, before we get into the details of callbacks and higher order functions, we're going to, like I said, establish some context, some shared language, shared vocabulary, and understanding with just a few of the fundamentals that we need to know about and define in order to really get into the details. So we're going to use this simple code block here on the right, just as an example of how we're going to go about diagramming tonight. We're not yet talking about higher order functions or callbacks. There's no higher order functions or callbacks on this screen, but we are going to use this code snippet. Before we do that, before we get into the code itself, we're just going to go through a couple of concepts. The thread of execution. Who wants to take a stab at defining what the thread of execution is? Any volunteers? Cool. We will then go over to Nathan. Nathan, what is the thread of execution from your knowledge?
I think it's kind of JavaScript's placeholder on where it's kind of keeping track of what code to execute. So it's kind of like where the JavaScript engine is kind of running each code and kind of what's at its like priority.
Yeah, that's a great way to describe it. The thread of execution is, well, first we should say JavaScript is single threaded, which means it does one thing at a time. It's never going to be doing more than one thing at a time. And it's going to read and execute the code in a very particular order: left to right, top to bottom, one thing at a time. And so the thread of execution is going to indicate where JavaScript is in the code, just like Nathan said. And this is important when it comes to callbacks, and we'll see as we get to the diagramming a little bit later in the workshop. Also, memory. Connor, what do I mean when I say memory in this context?
Yeah, sure. It's just a place, depending on if it's a global context or local context, to store a value that can be assigned to a variable, for example.
Yeah. So this is where we're going to store our data. And just like Connor said, we will use labels to then access that data. So we're going to store our data here with some labels so that we can access it later. And we might have a local memory for a particular function, but we'll also always have a global memory. We'll look at both of those as well. And finally, functions. Functions give us a way to wrap up some set of instructions that we want to repeat. And again, here we can give these functions, these function definitions, a label, and then invoke them where we see fit. So we're going to get into all of these things today. But first, before we go any further, let's do some diagramming. Okay, y'all. So like I said, this is a participatory workshop. This is a great opportunity for y'all to practice that technical communication. So let's start with Irene. Irene, will you walk us through this code as if you were the JavaScript interpreter, line by line, starting over here on this very top line here?
Yeah. So we're currently in the global execution context, and we are declaring variable num and assigning it to 3 inside the global memory. Then we are going to, how do you say it? We're going to, the technical way of saying adding the function multiply by 2 in the global memory. I'm blanking on how to say it normally, and we assign it the function definition.
Indeed, we are going to declare a function. Declare is a fine word, or define a function with the label multiply by 2 and store its function definition in global memory. Awesome, Irene. Great job. What happens next?
Okay, so then we don't go through what's inside that function, and we move on to the constant output line, where we are declaring a function called output. And
are we declaring a function called output?
No, we're declaring a variable called output.
And to be super specific, in this case, we're declaring a constant called output. Let num, this is a variable because we're using let, const is going to stand for constant. Okay, but yes. Okay, what is output? What is the value associated with output going to be?
So the value would be the invocation of our function multiply by 2 with the argument num.
All right, awesome. Before you go on, I just want to rewind just a little bit to anyone who's wondering, why didn't we look at this at all? You said that JavaScript reads left to right, top to bottom. Whenever we define a function, folks, we are not invoking that function. So it doesn't matter what the instructions are inside of our code block, inside of our function definition, until the function is invoked. And Irene, how do you know that multiply by 2 is being invoked on this line?
Because it is stating the name of the function followed by parentheses.
Yes, y'all, these parentheses are the key. I know there are parentheses here as well, but we also have the function keyword and our set of instructions. So function definition, function invocation. Thumbs on the difference between these two things. Cool. All right. Okay, so Irene, keep on going. So we've invoked this function. What does that mean that we need to do?
We are going to weave the thread of execution into
Yeah, you're right on. Into where?
Into the local execution context of multiply by 2.
Indeed. So right now, the thread of execution, y'all, before we have invoked this function, is in the global execution context. That's what this little arrow is here. This will be the thread. And now that we've invoked multiply by 2 with the value of 3, we are going to open this local execution context, which looks just like the global execution context. It has memory and it has this execution area, right? This execution context, but it's going to be local to this function. So Irene, what is the very first thing that we need to do whenever we open a local execution context?
We're going to push a stack frame into the stack that's currently not there. Is that what you're looking for?
We're going to leave the call stack out of it for this time around, but you are correct. The stack frame will be pushed on the call stack. What do we need to do in terms of our parameters and arguments here?
We're going to pair our argument with our parameters.
And
So
what is our argument? Or excuse me, what is our parameter?
our parameter here is input number inside our function, and our argument here is num.
And what is the value of num?
Num is 3.
Okay, so we are going to pair input number with the value 3. Parameters, friends, are placeholders in our function definitions for some argument that will be supplied when the function is invoked. So the placeholder is input number. This is going to be replaced with whatever we pass in to the function when it's invoked. In this line, we're passing in num, which is valued at 3. Okay, awesome job. Irene, what happens next?
Okay, so now we have our argument, so we can look inside our multiply by 2 function, and here it is declaring constant result and assigning it to our input number times 2, and our input number here is 3. So
3, what is 3 times 2?
And in the next line, we're returning our result. So we're returning 6 back to output in our global memory.
Awesome. Awesome. Yes, we are turning it to output because whenever we return from a function, we will return to where it was invoked. And so it was invoked as the value of output. So indeed, we are going to return to output in global memory. What happens to the local execution context, Irene?
It is moved away to, what's it called, the garbage?
Yes, y'all, believe it or not, this is the proper technical term. The execution context is going to be staged for garbage collection. JavaScript's going to come through and take it out with the trash. Okay, awesome. So that is staged for garbage collection. I did not highlight enough of this. Try that again. And I'm going to make it smaller. The thing that happened that I didn't draw, that I'll draw right now, was the thread of execution comes back out of this local execution context and is now back in global. Awesome job, Irene. Great technical communication. We're going to go over to someone new to walk us through this last line. Let's go over to Diana.
Yeah, we're going to declare the constant new output and set it and assign and evaluate the result of multiply by 2 with an argument of 10.
And we're going to declare that where?
In the global memory.
Indeed, we are. Indeed, we are. And what do we need to do if we are invoking multiply by 2 here?
I mean, the result is going to be 20.
The result will be 20, but we're acting.
Oh, we're going to create, we're going to create the local memory.
We're going to open up a local execution context, which will include a local memory. You are correct. All right, and what happens with the threat of execution?
Thread of execution. What happens with thread of execution?
It's going to weave its way on into this local execution context, because again, the thread of execution is how JavaScript keeps track of where it is in terms of executing this code. And so now we've moved into out of the global execution context and into this local execution context.
Mhm.
Sound good?
Yeah.
Cool. What is the first thing that we need to pair once we are in this local execution context?
So we're gonna pair the parameter input number with the argument 10. So the input number now is 10.
Awesome. And then what happens?
And then we multiply 10 by 2.
What do we need to do with our local memory first before we multiply 10 by 2? So we in our
Not sure.
local, no worries, no worries. You're doing great. You're doing great, Diana. So in our local memory, we've paired our parameter input number with 10. And then inside this function definition, we have moved on to this line. So what are we going to do with this label result?
Oh, we're gonna declare the constant result again, right?
Yes, indeed, we are. And this is a key word. We are doing this again. Yes. And now what are we going to do?
And
with the result?
well, yeah, now we're gonna return the result that is 10 multiplied by 2, and that
And
is 20.
it is 20, and then we will return it. So first we will calculate it, right? We'll calculate this whole number. It will be stored. Oops, it will be stored in local memory, and then we will return that number out to the global memory.
To the global memory.
Awesome, awesome. What happens now?
We exit the local execution contents, and we do this garbage cleaner
Garbage collection.
collection, right?
Yes. We mark this as eligible for garbage collection. The thread of execution comes back out into the global execution context, and we have run all the code. Awesome work, Diana and Irene. Great job, y'all. Again, we haven't dug into callbacks yet. We're just looking at the thread of execution, memory, and functions. Thumbs on these three things. Any clarifying questions on these three things? Cool. All right, y'all. Let's talk about functional programming. So one of the things, all these concepts combined together is going to contribute to this broader concept of functional programming. And this paradigm has a few key characteristics. One is pure functions. And by pure functions, I mean that there are no side effects. Let's see, instead of calling on someone, anyone want to take a stab? Raise your virtual hand. What are pure functions? What do I mean when I say there are no side effects? Yes, Russ.
That means it doesn't have any effect on like variables outside of the function. So everything is kind of contained within that function.
Yeah. There are no changes outside of that local execution context. For the same input, we will get the same output every time. Pure functions. Also, in functional programming, we have higher order functions, one of the topics of today's workshops. Why is it not highlighting? We will leave it. Okay, so higher order functions, we're going to get to this definition in a few after we go through our diagrams. But for now, know that this concept of higher order functions is what's behind these high high-level built-in functions, filter, map, reduce, for each, things like that. And they're going to allow us to write more readable code. And we'll see this, but you'll appreciate this bullet more and more as you spend more time writing code and reading other people's code. Didn't mean to select that. And then we've already spoken about this, not just the Codesmith technical interview, but this is certainly going to be part of other interviews as well. So we are going to do this quick thought experiment in terms of to explore why we have functions. Okay. Is this the right color for this? Let's choose a new color. I need to like build out my color scheme for notability. All right. So for now, let's do this. So there's some instructions here on the left, and I'm going to ask Spencer, will you tell me the code that I would need to write or type in order to create a function 10 squared based on these instructions?
Yeah, sure. So it takes no input. So I mean, you'd have to declare the function.
Yeah, tell me like the exact words that I need to write. Be very explicit.
Okay, so you'd write function, and then you do the parentheses. And you're not passing anything. So then you do the curly bracket thing, the start of the and then you put one at the bottom to like end your function. And then inside of your function, you would just return 10 times 10.
Awesome. Yes, yes. And indeed, this is a valid function, y'all. We've bundled up some instructions. The instructions are 10 times 10. And what label could we give this function?
Oh yeah, we could call it like 10 squared.
Yes, let's do that. Move this over. Well, I guess I didn't need to move all of that over. I'm going to move these over and call this n squared. And so how would I invoke this function?
You would, below it, you could just write 10 squared. And then, yeah, with the 2 parentheses.
And y'all, this would return 100. Because 10 times 10 is 100. Thank you, Spencer. Okay, awesome, awesome. Let's say we also want to be able to calculate 9 squared. Julia, what would I need to write in order to define a function 9 squared that takes no input and returns 9 times 9?
You would write function called 9 squared in the parentheses with no input, and then the squiggly brackets. And then inside you would return 9 times 9.
Awesome. 9 times 9. And how would I invoke this function?
You would write 9 squared with the parentheses.
And this would log 81. 9 times 9 is 81. Or this wouldn't log 81. This would return 81. Should be super specific there. Awesome. 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 One more. Let's do one more. We'll go over to Kiana. What about 8 squared? What if I wanted to define a function 8 squared?
So if you would just write below 9 squared, you would write function and then give it the label 8 squared, and then empty parentheses because we're not pushing any, not setting any parameters. And then you're gonna open the function with curly braces. And you're just going to say within the function execution block, you're going to say return 8 times 8. And semicolon.
Times 8. And how would I invoke this?
You would, below the function, just type, well, write 8 squared parentheses.
And what would this return?
64.
64. Yes. Who was the math teacher? Were you the math teacher? No, it was Sophie. Yes. Is our math correct, Sophie? All right, y'all. We could do this all day, right? We could write 10 squared, 9 squared, 8 squared, 7 squared, 6 squared. We could go all the way up and all the way down, all the numbers. But what principle are we breaking by doing this?
Dry.
Yes, we are breaking the dry principle. What does that stand for?
Don't repeat yourself.
Don't repeat yourself. Don't repeat yourself. Don't repeat yourself. Don't repeat yourself. Yes, this is one of the principles that we want to practice when we're writing code. And so there is a way that we could avoid this. I shouldn't have scrolled yet. Let me see. Let me ask. How could we avoid this? How could we avoid having to write a new function for every number that we wanted to square? Raise your virtual hand if you have an idea. Yes, Andrew.
Sorry, I keep disconnecting here for some reason, but
No worries.
I guess we can create a function instead of labeling it with a specific number squared. We'll keep that label to be num squared, and for the input, we can for the definition, we'll return num times num. That way we can use any number we want.
Walk me through it again. So we're creating a function with the label num squared.
Yeah,
And
so we'll declare the function num squared written in camel case with the input as num.
And instead of input, what is this called? What did we say this is
Oh,
called?
I'm sorry, parameter.
Yes, a parameter with the label num. All right. And then what would we return?
And we would return num times num.
Num times num. Yes, y'all. Look at that. Now we can pass whatever number we want into square num. I guess I called it something slightly different, but we are on the same page. We can pass anything we want. We can pass 10, 9, 8, or any other number and return the multiplication of that number and get it square, right? We can, the concept here is generalization through parameters. And again, parameters, they're just placeholders. We use these placeholders so that we can dynamically decide what data we want to provide to the function, not when we define it, but when we invoke it. Thumbs on this concept. Okay. Any questions at this point? Okay, I'm going to say this again because this is the concept. This is higher order functions are built on this concept. They follow this same principle that we can decide what functionality or data that we want when we invoke the function versus when we define it. Mind-blowing. Let's explore what the heck I'm talking about by looking at some more code. I'm just going to erase a few of these. All right. Okay, so we're gonna continue down our thought experiment and look at some slightly more complicated functions. Not super complicated, but slightly more complicated. So here we have a function definition: copy array and multiply by 2. It's going to take in one argument, and we're going to use the parameter array for that argument. And let me turn on my pointer here. Within the function definition, basically we're going to be iterating over that array. And for every item in the array, we are going to be performing some math on that element and pushing it into another array output, which ultimately we return. So that's what this function definition does, right? We have some other code here where we are defining an array, and then we're invoking this function, passing that array in as its argument. So let's diagram this piece out and take a look and see what happens here. Let us go over to Brian. Brian, will you, with your best technical communication, walk us through the code starting at this very first line here?
Okay, so we're gonna define a function, copy array and multiply by 2, and store in global memory with the function definition of that function.
Indeed, and y'all, I'm not writing that out.
Okay.
So we're gonna abbreviate it. Okay, so this is the symbol. We saw this before with our multiply by 2 function in our first diagram. This is a symbol we're going to use to denote a function definition being stored in memory. Okay, where does JavaScript go from here?
Down to const my array.
Yes, y'all. JavaScript does not care yet what is inside our function definition because we have not invoked it. So it's going to say, great, we're going to wrap up all these instructions stored in this function definition and then go straight on down to this line. Okay, walk us through that line.
Okay, it's going to declare the constant my array and store the array 1, 2, 3 in global memory with that label.
Indeed, it is. So this array has 3 elements. They're all numbers. The numbers 1, 2, and 3. How fantastic. What happens next?
Next, we're going to declare a constant result and assign it to the evaluated result of copy array multiplied by 2 with the passed in argument of my array, which is 1, 2, 3.
And where are we going to store this constant?
In global memory.
Cool. So here we go. And JavaScript does not yet know what this is going to evaluate to, so we'll leave it blank for now. But we have invoked a function. So what do we need to do, Brian?
Open up a local execution context.
All right. And this local execution context is going to be associated with our abbreviated copy array and multiplied by 2 with this argument passed in. How many arguments have we passed in to copy array and multiply by 2?
1 argument.
1 argument, y'all. This is an array with multiple elements, but we have still just passed in 1 argument. Okay, Brian, what is the first thing that we need to do after our thread has weaved itself in?
We'll store that argument in memory for the array parameter.
Yeah. We are going to pair our array parameter with our argument. 1, 2, 3. Okay, awesome. What's next?
Then we're going to declare a constant in the local memory with a label of output and set it equal to an empty array.
Indeed, we are going to set it equal to an empty array. Awesome. What happens next?
We're going to, in the execution context, we're going to perform the for loop.
Indeed. All right, I'm just going to set this up. We are going to be looping over our array. These are the elements. What is I currently?
I is currently 0, and it will push array at I, so the array at the 0 index, and push that value multiplied by 2 into the output array.
This is true. This is all true. I just want to slow down just for a moment, just in case anyone here is still coming to terms with for loops. So the first thing, we have this value initialized. I is initialized to 0. And then we are going to check to make sure our condition is true.
Okay.
So is I less than the length of the array, Brian?
Yeah, that evaluates to true.
Yes, it does. Okay, awesome. So then you are correct. We are going to push whatever is at the 0th index of our array times 2 into our output array. So what is at the 0th index? What is the element there?
1.
Indeed. So we're going to say 1 times 2. And what is 1 times 2?
2.
Tough math here. Okay, yes, 1 times 2 is 2. So we're pushing that right on into our output array. Okay, what does JavaScript do next?
I will increment +1.
Yes, we are going to increment I by 1. And then what happens?
The I will evaluate to less than the array's length. And it'll
Indeed,
enter.
one, just to be super clear, the length, y'all, is 3, so 1 is less than 3. And then, yes, we will enter the block. What does the block say?
To push the evaluation of array at the 1 index by 2, which will be 2 times 2. And that will be pushed, that result will be pushed into the output array.
All right, so we are adding 4 as another element. We are pushing 4 into our output array. Did I lose anyone on why this is 2 times 2 here instead of 1 times 2? Are we all good on this? Cool. And I'm just going to say it anyway, just in case anyone's afraid of saying you lost me. The element at index 1 is the number 2. We're at index 1. The element there is number 2. Cool. Okay. You are doing great, Brian. What happens next?
We will increment I to 3 or to 2, sorry.
Awesome.
And then 2 evaluates to less than 3, which is the length of the array.
Mhm.
And then we'll push the evaluated result of array at the index of 2, which is 3 times 2 into the output array.
Indeed. All right, and then what happens?
I will increment to 3, and it will evaluate the false as 3 is equal to array.length, not less than.
Awesome. Great job.
And
go ahead.
And then we'll return the output into global memory, closing the thread of or closing the local execution.
Indeed. Also, the thread has woven itself out back into global memory, and our local execution context is staged for garbage collection. Thumbs on what happened here? Any questions? Shout outs for Brian for his great technical communication. Awesome job, Brian. Yes, John.
Just a quick one. When you start a for loop, are you declaring a for loop? What's the correct vocabulary around that one?
I think you could say instantiating a for loop, initializing a for loop. Either of those would work. I don't know if I think declare would work. I don't know if anyone would like look down on you for saying declaring a for loop. I think I've heard initialize more often than declare though.
Thank you.
Yeah. Love the commitment to technical precision in the room, y'all. All right. What if we wanted to copy an array and divide by 2? So we wanted to copy an array and multiply by 2 before. Now we want to copy an array and divide by 2. So we're going to look at this function definition real quick. What does it do? It takes one argument and it's going to iterate over that whatever arrays passed in, and it's going to take each element of that array, divide it by 2, and push that result into an output array. This looks a little familiar. There's a slight difference. So let's diagram this out. And what do I need to include in this diagram, John?
A global execution context that will include global memory.
Indeed, indeed.
And I would love to see an arrow that is the thread. That would make me happy.
It would make me happy as well. Let's see. Here we go. This is why I draw these out in advance, because I take way too long to write. All right. There's the thread currently in the global execution context. And John, why don't you walk us through the code starting at the top here?
All right, we are, is this the question I just asked? Or is this something different? We're initializing, we're declaring it at this point?
Yes, we declaring or defining a function, either of those is valid.
So we're declaring a function copy and giving it the label copy array and divide by 2. And we're storing those with the instructions in global memory.
Awesome. And where does JavaScript go from here?
It's going to skip that function definition and drop down to declaring my array, the constant my array. And that's assigned with an array with 3 elements, 1, 2, and 3. And that will be stored in global memory as well.
Awesome. And what happens next?
We will declare a constant result and assign it the value of remind me the phrase.
The evaluated result.
Evaluated result, thank you, of the function copy array and divide by 2 with the argument my array.
Awesome, awesome. So we're invoking a function here. What do we need to do?
Okay. So we will open up a local execution context for that function.
Aren't these stickers great? Yes, we will open this up, and this is, I'm just going to use my abbreviation, divide by 2. And what is the argument here?
The argument is my array, so we'll pair that with the parameter of array in local memory.
All right, so we have our array parameter, our placeholder, and we are going to assign that the value of my array, which we see out here in global memory, has an array with 3 elements, 1, 2, and 3. Great. What happens next?
So we can jump inside that function now and declare a variable constant output and assign it the value of an empty array.
And what happens next?
And then we are going to start this for loop. Tell me how you would say that again, Laura.
Yeah, we will instantiate a for loop.
So we'll instantiate a for loop, and we'll declare a variable I and assign it the value of 0. The condition will be that the value of I is less than the array's length, which is 3 in this situation. And then inside.
Is I less than 3 in this scenario?
Right now it is. It's 0, which is less than 3.
Okay. So what are we going to do?
So we're going to push to output the array value at index 0, which is 1 divided by 2. So push the value of 0.5 to output.
All right.
And then we'll increment I by 1, and we're back in that for loop. Look at that condition. I is now 1. Is that less than 3? It is. So this time we will push array at index 1, which is equal to 2. 2 divided by 2. That will push the value of 1 to the output array. And then we will increment I by 1 again. I is now 2. 2 is less than 3, so it passes that condition. And this time we will push to output array at index 2, which is the number 3. 3 divided by 2. So 1.5 will be pushed to that array. We will increment I again by 1. It no longer passes that condition. 3 is not less than 3. So we are done with that for loop, and we will return output to global memory.
And where in global memory specifically?
We will, so if it's been undefined, are you reassigning it?
No, not in this case. It's only undefined because we haven't yet evaluated the result. But once it is evaluated, we can store this as the value of the constant result.
Okay, so store it as result in global memory, and then we will pop that off the stack if we were illustrating that, and garbage collect this local execution context.
Indeed, indeed. The local execution context is staged for garbage collection. I just added the thread in there. It had gone in, we forgot to draw it, but it had gone in, and then it has woven itself back on out into global memory. And you're correct, if there was a call stack here, this would be popped off the call stack. Awesome work, John. Awesome technical communication. Some great technical communication all around tonight. Just realized we've been looking at the sidebar this whole time. How are we feeling about this piece? You might already have a sense of where I'm going with this. Thumbs on what we've looked at. Cool, cool. All right. What if we wanted to copy the array and add 3? Yeah, we're not going to diagram this one. But do we see, are we all starting to see the principle that we're breaking here? What is it? What principle are we breaking? Let's go over to the chat. I just see, the only piece I see from the chat are the bubbles that pop up. I don't have room on my screen to have it up the whole time. So I do see lots of people saying dry, and you are correct. We're breaking the dry principle. We have a fair amount of repetition happening in this work. And so let's just look at all 3 of these function definitions and identify what's different about them. Of course, they have different labels. Those are different, but they're all taking in an array as an argument. They all have this const output. They're all iterating through that array with a for loop, and they're all returning that output array. What is different? This is like Highlights magazine as a child. I'll give you all about 30 seconds to look at this, to formulate your responses, and then I'm going to pick someone, or maybe 2 people, to talk about what is different. So just take 15, 30 seconds. Okay, let's do it. Christian, what is the difference that you see here?
The difference I'm seeing is that in lines 3 and 4, that code block, we're just changing the math that we're pushing to the array that we declared.
Yeah, we're changing the math, like the functionality. In one, we're multiplying, in another, we're dividing, and finally, in this last one, we're adding. And we saw before how we could we could make our function dynamic by using a parameter for our data, right? Like we already saw how we could change this number dynamically with a parameter. But how could we change our functionality, the type of functionality that we're performing at runtime? How could we solve that problem? Guess what? We can solve it with callbacks. So let us look at copy, array, and manipulate. So this function definition, some immediate things that I'm realizing are different. It's taking in 2 arguments instead of 1. Okay. It also, inside of our push invocation here, we are, instead of doing some math, we're invoking our instructions parameter. Without even seeing this last line here, can I cover it? Not really. Without even seeing this, we can intuit that instructions, whatever we pass into instructions, must be what? What must this be paired with? What data type? Kiana?
A function.
Yes, a function definition. And why do you say that?
Because if you look in the execution block of copy, array, and manipulate, you see instructions is it's taking an argument into it.
It is.
Which is something a function does.
And even at a more high level, not all functions take arguments, but this function is taking an argument. The parentheses are key here, right? Even if we saw parentheses without an argument, we would know that this is an invocation of a function definition. So we looked at how we could generalize our function earlier by changing our data. What was the num squared, right? Num squared. Spencer walked us through that one. In this instance, we are generalizing our functionality by passing in a function definition. Okay, let us diagram this one out. This one I always have trouble fitting on the screen, so we're gonna do our best. All right, here we go. I'll change colors as we go along. Let's see, who is it going to be? It's going to be Zach. Zach, do you want to walk us through this code here?
Sure. So, starting in the global memory, we are going to declare that function, copy array, and manipulate. And it's going to take array and instructions now.
Yes, it will take array and instructions, but remember, we're not invoking this function definition yet. We're just declaring it. So what does JavaScript do at this point, at the time that we're declaring or defining this function? What's the value going to be associated with this label?
Right. Yeah. It was that little symbol that you drew earlier. I can't remember what you called it though.
Yes, the function definition.
Function definition, right. Okay.
And where is JavaScript going to go next from here?
Now we'll skip the code blocks since we don't know what we're putting in yet. And we go down to function multiplied by 2, and we do the same thing, putting that in global memory.
More abbreviations, friends.
By 2.
Oh, Yes, another function definition is stored with this label. Okay, now where do we go, Zach?
All right, and skip again down to the end now, and we're going to declare a variable with constant result.
And to be super precise here, we're going to be declaring a constant. So this one won't vary.
Okay, gotcha.
Constants can't be reassigned, so we can use the label or the word constant to describe it. But you are correct, we are declaring result.
Yes, and as of now, it is undefined.
Yeah, we need to figure out what this is going to evaluate to. Why is it undefined? What will it evaluate to in the end?
It'll evaluate to the result of calling copy array and manipulate on 1, 2, 3 and multiply by 2.
Amazing. Yes. And I'm just drawing the thread, which is in our global execution context at the moment. What do we need to do, Zach, given that we are invoking a function here?
Yes, now we'll open up the global execution context window. So,
We're going to open, this is a local execution context. So we're
local execution.
global, but
Okay.
we are opening up a local one. And let me just write an abbreviation of what this refers to.
Yes.
And I'm just going to use a different color for this function definition. Okay. There's a method to my madness, folks. Put that there and good. Okay. Continue.
Okay, so now the first thing we'll do is store the first parameter of copy array and manipulate, which is going to be 1, 2, and 3 in the memory, local memory.
And what is the label again?
The label will be array.
Yes, awesome. So we're going to pair array with the argument 1, 2, and 3, or an array with the elements 1, 2, and 3. Okay, and then what?
And then I suppose we'll pair instructions with multiply by 2, the function definition.
Indeed. Oops. There it is. All right.
Okay, and now that we've paired those, we'll go into the function and declare a constant output, which is an empty array.
Before you do this, I've already recognized that I've made this too big, so I'm just making it a little bit smaller so that we have space for what's coming. Okay, all right, so yes, now we are declaring output. Fantastic. And what will this be?
Empty array.
Empty array. Awesome. Now what?
Now we enter into the local execution context to go through this for loop.
All right. And I will do what I've been doing. For the sake of our diagram, we have the array that we are iterating over. We have I, which is initialized to what?
0.
0. And what is our condition here?
Then we go and check if I is less than array.length. And array.length will evaluate to 3 in this case, so that should pass as true.
Awesome.
And then we'll enter the code block and to the output array, I suppose we're going to go into instructions. Yeah, I guess I don't know how to describe the exact order of this, but.
Yeah, no worries. You're doing great. You're doing great. So we're going to invoke instructions.
Mm-hmm.
So we will be pushing the evaluated result of instructions with the argument
array I.
What the argument is. What is array at I?
Array at I is going to be, in this case of I, 0, so it will be 1.
I'm just going to write this out here. So we're pushing instructions with 1. So this is a function invocation. What does that mean for our thread of execution and our execution context?
Right. So now we'll open up a new execution context window.
Where are my execution context stickers? Cool. So we are opening a new execution context. What is the first thing that we need to do whenever we open an execution context?
We need to associate it with the proper function.
Oh, yes, that is a good point. Let me add that here. This is instructions and the argument 1. Okay, and now what?
So I guess instructions will evaluate to multiply by 2 somehow.
What? You're right. It will be the function definition that's associated with multiply by 2. When you say somehow, how does JavaScript know that that is the case?
Because instructions in the memory of the local execution context of the first function evaluates to the function definition.
Indeed. In fact, just for clarity, let's put that here.
Okay.
Okay, great. Okay, go on.
Okay, so now we need to associate input with array I, in this case array 1, which is 1. Yeah. I guess it's just 1 because it already is evaluated to 1 before.
But we do still need to pair our parameter, because this is the function definition that we're referencing here. We do need to pair our parameter input with 1 so that JavaScript knows what to do when it gets to any part in the code in that function definition that uses input. So you're right on. So we're going to pair input with the argument 1. Okay, now what happens?
So now we go into the code block and we return, I guess we go to the execution context and we take that input and we multiply it by 2.
We have input of 1 times 2 is 2. What are we going to do with this number?
Now we are going to return that. So I guess bring it back out into the previous execution context.
Yes.
Or put it in memory.
We are going to, remember what we were evaluating here, y'all, was this function invocation, right? So now, instead of instructions 1, this is going to be 2. And what are we going to do with 2?
We're going to push it to the output array.
Indeed we are. Here it is. All right. What happens to, we forgot our thread. This is my thing I'm always forgetting to draw. What happens to our thread, which was in this instructions local execution context? Where is it now?
Now we just evaluate push to 2. So yeah, it goes back there. Then that pushes to the output.
Awesome. And we will garbage collect this local execution context. We are done with this completely, right? There's nothing else that we're going to do with this local execution context. Yes?
Yeah.
Cool. All right. So then I'm going to erase that. I'm going to leave our function symbol just for ease of what's going to happen next. So this is pushed to output. We are, I is still 0 at this point. So what is going to happen at this stage? Now that we've run through this line where
Yep.
I.
So now we've gone through that first iteration of the code block. Then we iterate I++. So I now equals 1.
I equals 1.
And then we go and evaluate I is less than array.length, which is true still.
Awesome.
Then we're going to enter back into the code block. Then output, we do the same thing with the function, yes. And now we pass in array I at 1, which will evaluate to 2.
Okay, here we go. What do we need to do? What do we need to open up?
Yeah, so same as last time. Now we're going to open up another execution context, local execution context.
And I'm going to make it an appropriate size. Awesome. What happens to the thread of execution? We remembered this time.
Yes, thread of execution. So we're going to associate input with 2 now.
Before we even start pairing our parameters and our arguments, the thread of execution is going to weave its way into this local execution context. Thought I was trying to draw a straight line. And yes, now we will pair our parameters and our arguments. So go ahead.
Okay, so input is going to equal 2 now.
All right.
And then we are going to return input multiplied by 2. So 2 times 2 equals 4. And then with the thread of execution, we're going to return that back to our previous execution context and trash that local execution context.
Indeed. And the technical term is garbage collection. It will be staged for garbage collection.
Gotcha.
Although trash is a fantastic shorthand for that. So 4 is going to be, what is going to happen with the number 4?
Now we're going to push 4 into the output array.
Back to that erasing in a moment. Okay, and I'm just going to, just to be super clear, this will have been garbage collected, y'all. I'm just removing the necessity of me resizing another local execution context. All right. Now, we have iterated through this line a second time with I at 1. Christian, I see that you have a question, so we'll pause the diagram for a moment. And Zach, awesome job, great technical communication here. Christian, what's your question?
I just had a question. When we are diagramming, for instance, when we're invoking instructions, would that local execution context be inside of the prior local execution context, or are they diagrammed one on top of the other like this?
Yeah, this is a great question. So and just to reiterate the question that Christian is asking, and also to make sure that I'm understanding the question that you're asking, I believe your question is the execution context actually being opened up inside this other execution context? Is that your question, Christian?
Yeah, that was my question.
Yeah, and that is indeed what's happening here, right? We're not going to draw it that way because I would never be able to fit it. But that is indeed what's happening here, right? So this, just like this local execution context, is nested inside the larger global execution context. Any invocation that we make inside of a local execution context will indeed be nested inside that local execution context. Thumbs on this, y'all?
Thank you.
Yeah, great question, Christian. Yeah, John.
Along those same lines, is there any other way to refer to it other than like a local execution context within a local execution context? Do you just use those labels for the functions? Is that how you would differentiate in speech?
So something that we haven't been including in our diagram, but is happening alongside here is the call stack. And so what you would refer to this is whichever function, whichever execution context is stack frame is on top of the call stack is where our thread of execution is where JavaScript is currently executing code. So to technically communicate that, you would probably be talking about the frame that is on the top of the call stack. I'm not going to draw all this out, but we will imagine this here. And so as things are popping off the call stack, that you would technically communicate around it via the call stack.
Great, thank you.
Yeah. Yes. And y'all, if you want to do some diagramming with the call stack, come back to another hard parts. I think every other one we will focus very much on the call stack as well, including recursion and closure. Okay. Christian would love to have you walk us through the last piece here. So just to refresh everyone's memory, because we did pause there, we had just finished running this line of code when I was 1. So Christian, what will happen next from here?
Let's see. So we just push forward to output. We are going back to the condition after we've incremented to I being 2.
Awesome.
And now we are, let's see, opening another local execution context.
Before we do that, let's just verbalize that conditional check here. Is I less than array.length? What is I? What is array.length?
Array.length is 3.
Mm-hmm.
So 2 is less than 3.
Awesome. Okay, go ahead.
And now we are opening another local execution context for instructions and weaving the thread of execution into this new local execution context. And let's see.
And what is array of I here?
Array of I is 3.
Awesome. And what are we going to do with that value of 3?
We are pairing the array, or sorry, the argument and parameter. So input equals 3.
Awesome. Now what?
And then we're returning 3 times 2, which is 6, into the index of 2 in output in the local memory of the above local execution context.
And our thread of execution has gone back in. What happens to our local execution context?
It becomes eligible for garbage collection. And then I think we're done, right? We would return.
What JavaScript know that we're done?
We would return output, which is the array of 2, 4, and 6 to result in the global memory.
We even do that, before we even get to this line, how does JavaScript know that we're done with our for loop?
Oh, after we finish that, we increment I, so I would then be 3, and 3 is not less than 3.
3 is not less than 3, so we're done with the for loop, at which point we can move on to this wonderful line. You are correct. And where are we returning?
We're returning to the array 2, 4, and 6 to result.
Awesome.
And then that local execution context becomes eligible for garbage collection. The thread of execution moves back into the global execution context.
And then we are done.
Yes.
Awesome job, Christian. Awesome job, Zach. Y'all, this was a doozy of a diagram. Great work, great patience as well. And this is it. This is us using functionality, parameterizing our functionality, not just our data, not just the number that we want to pass, but also a function. And when we, well, I won't give it away. I will ask y'all about this in a moment when we get into definitions of callbacks versus higher order functions. But let's first talk about why this is possible in JavaScript. How is it possible that we can pass a function definition to another function? The main reason that this is allowed is because functions are first-class objects. This means that they can be stored in a variable. They can be passed into a function. A first-class object can also be returned out of a function as well, which is a teaser to the closure hard parts workshop. But we can return a function definition from another function when functions are first-class objects. So this is the concept that this is built upon. And this, I guess, now that I'm reading these words, this is what I said, right? They can be passed as arguments into functions. They can be returned as values from functions. They can be assigned to variables and properties of other objects. We've been to the functions and objects intro to JS. We know that when we assign a property on an object to a function definition, it's called a method. This is all possible because of this first class objects distinction. So, which is our higher order function and which is our callback? Let's start with higher order function. Pedro, which of the functions on this screen is a higher order function, if you had to guess?
Pretty sure it's multiply. Sorry, pretty sure it's copy, array, and manipulate now.
Yes, you sound like you are guessing, but you are correct. Copy, array, and manipulate. I'm writing it all out now, and it's taking me forever. Manipulate is the higher order function. Higher order functions can take another function as an argument. This is what makes copy, array, and manipulate a higher order function, is that it takes instructions as an argument. In this case, it takes multiply by 2 as an argument. Instructions, as we talked about, is the parameter. With that said, is there anyone else I haven't heard from yet? I think I've heard from everyone. Julia, which of the functions here is a callback function?
Would it be multiply by 2?
Would. It would. Multiply by 2. A callback function is passed as an argument to another function. And that's the only thing that makes it a callback function. If this function definition, multiply by 2, was never passed to another function as an argument, it would not be a callback function. All right, let's just look at the proper definitions of these. Highlight these again if my highlighter works. So, a higher order function, it takes in a callback as an argument. The outer function that takes in a callback. You could also a callback, or excuse me, a higher order function, a function that doesn't take in a function as an argument, but returns a function as its return value, a function definition, is also a higher order function. So you'll see those as well, particularly as we start to work with closure. Callbacks are functions that we pass in as an argument. And just to be super clear, we are not invoking multiply by 2 when we pass it in. What we're passing in is the function definition itself. Yes? No invocation here. The invocation happens inside our function definition. Let's do a little quiz. Let's do a little quiz. Why not? The answers are probably on the screen, but that's okay. Brian, what makes a function a callback function?
A function is a callback function when it is passed into a higher order function as a parameter.
Yeah. When it's passed as an argument to another function, it is a callback function. And Sophie, what is a higher order function? What makes something a higher order function?
It takes in a function and also passes out a function. I'm trying really hard not to read the screen. There.
Yes. Let me just cross. No, I can't cross it out. Yes. What is a higher order function, Sophie? Say it one more time.
It takes in a function and also passes out a function.
Yeah. So quick distinction. It takes in a function as an argument, or it returns a function. So a function can take in a function as an argument. It doesn't have to also return a function. Either one of those characteristics will make something a higher order function. Thumbs on this concept, y'all? Doesn't have to do both. In fact, we didn't see any of these functions returning a function definition. Cool. And why is this possible? Connor, why is this possible? What are functions in JavaScript?
They are first-class objects.
Mm-hmm. They are first-class objects. They get special treatment because of this fact. This is taking way too long to draw, but it is worth it because they get first-class treatment. Okay, yeah, Hansa.
Can we get an example of a higher order function returning a function definition?
Okay, y'all, there's nothing special about higher order functions other than those two characteristics. And I say that because there could be all sorts of use cases for higher order functions. The one instance, and this will be a great segue to the next workshop that maybe y'all will attend, the one instance where we will use a function definition to return another function definition is when we want to use a closure. So this hard parts is not about closure, so we're not going to go into it further than that, but that is a great example of when a function might return another function definition. It's when we want to use a closure. And I don't know when the next closure workshop is, but I promise there's one in the next 2 weeks. So if you're wondering more about that, here's your cliffhanger. Go to that closure workshop. All right, yeah, let's wrap it up here. So callbacks, higher order functions, they simplify our code. They keep it dry, right? We certainly dug into this concept, how without higher order functions, without being able to pass a function, pass some instructions as a parameter to a function definition, we would have a lot of repetition. So this is going to help us keep our code dry, both callbacks and higher order functions. Beyond that, and this is going to talk about cliffhangers to other workshops, asynchronous JavaScript is built on top of this concept. So if you haven't gone there yet, that's a great place to go after callbacks, is to kind of make that connection to how this is going to be used to defer some functionality to run later. It's built on top of this. This is also what gives us those super powerful, sometimes difficult to understand functions, native JavaScript, map, filter, reduce. These are all taking callbacks as an argument. For each also takes a callback as an argument, right? It's taking a function definition as its argument. And also, yes, of course, interview prep, whether you're prepping for the Codesmith technical or you're prepping for a technical interview for a job somewhere, being able to verbalize and understand what's happening under the hood with callbacks is going to serve you tremendously in that process. All right, y'all, thanks for sticking around. I appreciate you. I hope that this was helpful. I hope to see y'all back sometime soon.